All right, today's project is a really cool one. It is a Jazzmaster Thin Line. So these are chambered. You can see it chambered out down here. There's also a big chamber up here. Makes it very lightweight, gives it a very unique tone. Kind of a lot of work to these because we have to, make the blank thinner, then chamber that out, then glue the top on, then machine the top. But it's worth the work, so let's get to it. Hey, if you find yourself enjoying this kind of content and want to see more, why don't you mash down on that subscribe button? That helps us immeasurably. And then maybe punch the like button and give us a thumbs up and maybe comment and stuff. That helps us bring you more content like this. So please do that, it helps a lot. And now, due in part to the overly litigious society in which we reside, listen to my robot.
Danger, Will Robinson! Danger! No, Will Robinson! Danger!
All right, let's get to designing this thing. Don't let this complicated mess here, scare you. We'll go over it in a very easy fashion, and then, I'll try to make it very easy to understand. So the first thing we'll do is we're going to check our material. And the thickness is 1.5 inches. Now, it's normally 1 3/4, as you know, but we are just cutting the chambers in this one. So that 1.5 inches is the thickness of the chamber blank. We'll cut the chambers, then we'll glue on the 1/4 inch thick top, and that will bring it to 1 3/4 inches. So 1.5 inches is correct. All right, so we'll hit OK. And then we'll move this back to where you can see it. All right, so I have color coded these for you. The chambers here are in red, and the rest of the stuff is in black. And for right now, we don't need the rest of the stuff, the cutouts in the top and the pickups and the neck pocket, because we're not cutting those. All we're cutting right now is the chambers, because if you think about it, right, we'll have the 1.5 inch blank in the machine, and we got to cut the chambers first, then we'll take that out, glue the top on, then once it's glued back together with the top on, we'll take it back and cut all that other stuff. So what we can do, just for simplification, is we can turn off all of this other stuff. Okay? So there we have it. Now you can just see the chambers. And all I did is go up to here and the little light thing, turn it off. I wanted to keep the outer profile just so you could see how that looks, but okay. So we're just cutting the chambers, all right? So now it becomes pretty easy. It's not so confusing. And those chambers, we'll go over here and we'll look at them. And they're 1.2 deep. We'll make them 1.25. Okay, so there's a 1/4 inch thickness on the back. It's 1.5 inch blank. We're cutting out 1.25 inches. That's a 1/4 inch thickness. We are cutting out using my standard 6mm rougher. I have looked at it in the past and tried programming this with like a 3/8 inch end mill or an 8mm end mill, because it's wider and you think that it could, it would do the job faster. It does not. They're within a couple of seconds of each other. So instead of doing all the tool change and stuff like that, I just leave the 6mm. Okay, we're going to ramp the plunge moves. Okay, and we'll use a conventional cut. You can use a climb if you wish. Okay, and there's no pocket allowance because this all gets hidden anyhow. Okay, and you'll notice this kind of weird geometry right in here, and you'll see where that comes into play when we put the pickups and stuff in here. You can see why that is shaped as it is. But here we go. We'll calculate this. Okay, and that's what it looks like. We'll reset the preview. We'll preview all toolpaths. Okay, and that is what we're trying to make. I didn't cut out the outline so you could see where it is, but basically you're just cutting 2 pockets in there, and if you look at the 2D view, that's where the 2 pockets will go. Okay, So that's the easiest part. Now what we're going to do is I'm going to go back and I'm going to cut the other pockets, all of the other pockets that are in here. Okay, so I can turn those back on. The tremolo pocket, switch, pickups, and F-hole. Okay, so now they're back on. And just remember, when you save this toolpath, to just save this toolpath, chambers, because now we're switching it. Okay, what do you mean switching it? We're telling it that it's 1 3/4 inches thick now. Okay, so in your mind you have to remember that when you switch over, we switch it back to 1 3/4 inches thick. That will only become an issue when we cut around the outside here, but it will be an issue. So I would save this toolpath now, and now we can do the other toolpaths. Okay, so let's do those. All right, the way I like to do it is this toolpath right here, the control cavity, as well as the switch and the F-hole, those are all cutting through to the chamber, right? So they don't really need to be pockets. You can cut around the outside here and that piece will just fall out, right? Right. So let's do that first. We'll do all 3 of them in one fell swoop. We'll get this guy, and I'll hold down the shift key and select the F-hole. Then I'll hold down the shift key and select the control cavity. And that is going to be a profile toolpath. Okay? Now, that thickness of the top is 0.25 thick. So we only have to go 2.5 deep. I like to go a little extra because it doesn't hurt. Okay? I will go 0.3 deep. I'll use my same rougher. We want to go on the inside here because these are pockets. If we went on the outside, it'd be 6 millimeters, it would be 12 millimeters bigger. 6 millimeters on this side, 6 millimeters on the other side. So we don't need any tabs. I have found by experience that these pieces don't come winging out or anything, they just fall in. But if you'd like to put tabs on, feel free to do so. Okay. Just because I'm cutting through, I'll put a little tiny ramp on there. Okay. And what should we call these? We'll call it switch, F-hole, and control. Okay, so it's going to cut all 3 of those. There you go, 1, 2, 3. All right. Now we have to cut everything else. So let's go and we'll cut the pickups for this one. Okay, we'll select this pickup, hold down the shift key, select this pickup. Now, because this is solid in here, right? There's a chamber up here and there's a chamber down here. But this is solid through here. So we have to cut that as a pocket. All right, we'll cut it 0.75 deep or however deep. If you have pickups, special pickups, whatever, you can change that, but that's it. We'll cut it 0.75 deep, conventional cut. We'll ramp the plunge moves because it's going through solid material here. And we'll call these pickups. There we go. All right, how about next? Next, let's cut the tremolo pocket. Okay, so we'll do that. Select it. Remember, again, it's going to be a pocket because it's in solid material. Okay, and this is 1 3/4 inches thick. You can measure your tremolo. They do vary a bit. I've found imported ones vary quite a bit from standard ones. Okay. But we'll go, 1.5 deep. Okay, that should give you plenty of room, but measure yours. We'll ramp the plunge moves, and we'll call this tremolo. Now, I should also tell you that just because that tremolo is in here, you don't have to cut it. A lot of guys don't like the Jazzmaster tremolo. They want to put some other kind of bridge on here. That's fine. Don't select it, don't cut it. The geometry's there if you want to. If you don't worry about it. Put whatever kind of bridge you want to put on there. All right. Now, let's go to the neck pocket. Here we go. Again, pocket. You've seen me do this 100 times before if you're a friend of the channel. It's 5/8 deep or 0.625. 6 millimeter, conventional. We'll ramp the plunge moves again. We'll call it neck pocket. Okay? And we'll calculate that. There you go. Lastly, let's cut this guy out. Okay, so we'll get the outer profile. That is going to be a profile toolpath. And remember, since the top is on now, this is 1.75 thick. So 1.75, we want to go on the outside, right? Because that's our final dimension. I'm not going to put tabs on this one like I normally don't, just so I can show you I can get away. I can make the rest of the wood disappear. Well, it gives you a better 3D rendering, but if you need tabs, put those tabs on there. Ramps, you know, I always put a little short ramp on there. Take it easy on my bit. And we'll call this outer profile. All right, and we'll calculate that. All right, so watch what I do here. I'm going to leave, let's get it lined up. I'm going to leave the chambers out of it. I'm not going to put that in the preview. We already know what they look like. All right, so I'm going to reset the preview, and then I'm going to preview visible toolpaths. Not all the toolpaths, because it'll show you the chambers, but the visible toolpaths. And there they go. I'm going to get rid of the outside stuff. I'll move this up here. I'll give you an oblique view of it. And if you look at this, you're looking at this and say, what the hell is going on here? Look at these. They look funny. Well, remember, it's cutting through to the chamber. Okay? And again, here's where those funny geometry that I showed you before is there. So these are going to cut through. It's not shown on the rendering, but you know that they're in there. All right, just for grins here, let's do this. Let's reset the toolpath, reset the preview, and we will select all of the toolpaths and watch what happens when we preview all of the toolpaths. This is why I left the chambers out on the first one, because it looks like this then. Okay, and you can't see the F-hole or the switch cover or the other thing because it's all plowed out. So that's why I do that. Okay, so there you have it. This one's a little more complicated, but you know, I tried to go through it as systematically as possible so you'd understand a little bit. Remember, cut the chambers first. So if you're going to save the toolpath, just select the chamber toolpath and then do the save toolpath. Then you can select all of these and save that toolpath. So you'll have two separate G-code programs. The first one's for the 1.5" thick blank, which is just the chambers, and the second one will be for the entire body once you have that 1/4 inch top glued on. So don't get confused. You know, if you're at all hesitant, think about it a little bit. I'm sure you'll come out okay. All right, so now let's go into the shop and actually do some cutting.
All right, back at the lumber pile. Mahogany today. So this guy's right on top. He looks pretty good. Looks plenty wide enough to my calculated eye. We'll get him cut into some blanks. Okay, now we got our wood selected. Nice piece of mahogany. We'll cut her to length. All right, here we are at the glue-up table. I try to match these as best I can with grain and stuff. Use a glue dispenser, Tight Bond 1. 2 or 3 are a little more water stable, but we have found them to be rubbery. And have never had a problem with Tight Bond 1. Nice even glue coat. We'll line these up here, and we always go 1 clamp on either side. Gives you a nice clamping, even clamping pressure on both sides. Clamp it down fairly tightly until I just see some glue squishing out, and then we know we're good. Okay, because we're making a thin line, and the 8/4 wood that I get is what they call hit and miss on the planer. It's basically 1 15/16 of an inch thick. But for a thin line, we needed 1.5 inches thick. So we really have to plane a lot off of this. So let's get started. As you can see, I have the G-code loaded up for the chambers. So let's go machine that. All right, as per my usual, I use a template that I have just to make sure that the blank is the correct size and that I'm missing my clamps when I'm machining it through the center line on both the spoil board and the template. And it looks like I got plenty of room here. Additionally, you have to remember that this is only 1.5 inches thick. Okay, it's not 1 3/4 inches. It's 1.5 inches. So keep that in mind. I'm going to have to re-zero my Z to make sure that this cuts correctly, because I need a correct zero for that. So let's do that. Right there is a Z0. So I'm hitting the 0 button on my machine, sending her back to home, and I'll start to spindle. One other thing I want to say, some of you might be questioning my use of the 6mm bit when I'm just hogging out material, just making them big chambers. I have run the time estimation things on the CAD, and it's within about a minute, okay, just for the speeds and feeds that I use. So I just go with the 6mm. It just keeps my life simpler. I don't have to have more bits and all that kind of stuff. It also puts less side pressure on when it's cutting, so I don't have to worry about something slipping. Anyhow, I will hit the run button, about 18,500, and I will start my dust extraction. For the top, we basically want to make a blank that is only 1/4 inch thick, around 20 inches long and around 14 inches wide. We also want to make sure that the seam is right down the middle. So this is just a piece I had out of my scrap. It is 7 1/4 wide and it's 22 long. So this will work great. So what I'm going to do next is I'm going to joint both edges on the jointer. All right, I'm just going to use my benchtop jointer just because the piece is only 22 inches long, and I'm going to joint both edges. Both edges are nice and smooth and jointed. Now we have to go and make our lines to cut this. All right, this next part might get a little controversial for some of you. I know that from long experience, I can get 4 pieces out of this piece of 8/4. Okay, so I eyeball the middle, and then I cut each side in half. All right, that will give me 4 pieces. All I do, and I know there's all sorts of jigs and all sorts of fences and all sorts of everything that guys use to get a nice kind of a resaw, but here's what I do. I just make 4 lines, or 3 lines actually, and I just eyeball it. There you go. And all I do is follow those lines on my bandsaw. And you're going to say, well, this one's thicker than this one, and okay. They're actually a lot thicker than a 1/4 inch, but I have, again, found through experience that I make them thicker and then plane them down. That assures me that both sides are really flat. Okay, I'll plane them on both sides after I glue them together. So, to the bandsaw. This is the part of the video you guys have been waiting for, the part where I give you the free coupon code. Just go to the link in the description and it'll take you to the file page and check out like normal, and when it tries to charge you, just put in that coupon code and it'll be free. The only thing that I ask in return is that you subscribe to the channel. Subscription's free also. Doesn't cost you anything. Maybe, 2 seconds to click the button wherever it is. All right, let's get back to the video. All right, this is my setup on the bandsaw. I got her up and I just run it and make sure I'm holding it flat, and that's why I jointed both edges. This edge that runs against the bandsaw table, I don't want this thing getting sideways on me. So that's why I jointed that edge. I make sure I hold that down straight, and then I run this through the bandsaw and just follow each line by eye. I have found that that is the fastest, simplest way to do it. All right, so here's a couple of those pieces that I cut on the bandsaw. And again, because I have both edges jointed, I can put these any way I want to glue them together. And I glue them together just like I would a body blank with a couple of pipe clamps. Let's go do that. All right, this is my basic glue setup. I got some Tight Bond 1 in there, and I glue these like this. Now, I will tell you that when I do this, I do it with 3 clamps, because if I do 2 like this, I'll show you what can happen. If you tighten these too tight, and you can get them to pop like that. Granted, I had to help it a little bit because the edges are really square, but I always use 3 just to be safe. Okay, 1, 2, and then I put the 3rd one across the top here, and that makes it so it will not allow it to spring open like that. Let that dry overnight. Then I take the whole thing to the planer, just like we did the bodies, but this one I carefully plane it to a 1/4 inch thick. Okay, you can see I have the body with the top positioned in the vacuum table, and this thing, all this is a big bag with a vacuum hooked up to it. We use a 5 CFM, cubic feet per minute, vacuum pump that is hooked up to a vacuum reservoir, and there's just a tube that goes to a valve that goes to the bag. So when we turn that down, it evacuates this bag, and atmospheric pressure pushes down on this. I don't know what 14.5 pounds per square inch times 12 by 16 is, over 200 square inches. So it's like parking your car on this thing. I mean, there's 1,000 pounds or better pushing down on this. All right, as you can see, I have the G-code loaded up for the top, and you can see from the lines here that these 3 here, the switch, the F-hole, and the control cavity, are just profiles. They're just cutting through the top, whereas the neck pocket, the pickups, and the tremolo are pockets, because that's where it's solid underneath the top. So let's go machine this. Okay, so here's a 1.5 inch blank, 1.5 inches thick, with the 1/4 inch top that has been glued to it. And so that makes it 1 3/4 inches, our regular, our standard. And as you can see, this is a really nice book matched 2 pieces here on the top. And because we marked the center lines when we cut the chambers, when we glued the top on, we aligned this seam with those center lines. So now the seam and the center lines are aligned, and all we have to do is align the marks on our spoil board to line those up, which I have just done. Those will line up. The center line of the book match will line up with the center line of the chambers, will line up with the center lines that we have on the spoil board. So that's how we know that this is in the right position to machine the top. Okay, also what we're going to do is we're going to double check to make sure we're not hitting our clamps or anything else. So we line up the center line on our template with the center line on the top, which is lined up with the center line of the chambered blank, which is lined up with the center lines on the spoil board, and that all looks good. So let's go ahead and machine this. All right, we'll fire up the spindle, about 18.5 thousand with my standard 6mm bit. Here we go. Spindle's coming to speed. I'm going to turn on dust collection. She machined out, missed my clamps, everything looks good. You can see that the chambers lined up with the cutout in the top extraordinarily well, so this guy's ready to move on to the next step. Alright, so these thin lines are no different than regular ones. The first thing we have to do is remove these little tabs at the drum sander, so we'll do that. That's generally all there is to it. That router bit that I use leaves a pretty nice finish on these. So we'll take her to the next step. All right, so for the Thinline Jazzmaster, what we're gonna do is we're gonna run the orbital sander across the front, get rid of these little glue marks, take off the fuzzies, give a nice, smooth, flat surface for the router to run on when we do the roundover. So here we go. Here's the front, here's the back. Some additional glue marks, that kind of stuff. Now, when I say glue marks, I mean, when we're putting these together, sometimes some glue will get on the bench and we'll set this on there and you'll be a little glue mark that ends up on the wood. That's all that is. So, all right, now it also should be noted that since this is a thin line, there is no forearm cut or belly cut. If we were to put those in, they would go right into the chamber, and there'd be a big hole here, and a big hole in the back end. And you might say, well, you know, why don't you just modify the chamber so you can put those cuts in? And that could be done, but then you couldn't put the F-hole in because there would be no chamber back here. And we just don't see a market for that. So this is the way that we do it. All right, router 3/16 round over. You'll notice I eased these in and out right here so I don't intrude in this area for the neck plate. And Jazzmasters usually have the input jack come through the pick guard so we don't drill the hole here. So a little more hand sanding and this guy's done. Another guitar build on the shelves. This one was a Thinline Jazzmaster. Kind of a lot of moving parts in this one. You have the chamber, you have to machine the blank thinner. There's nothing on the back, so you don't have to line anything up, but still, it's a little more challenging than others. These are great because they're lightweight, they sound good. I really like the F-hole. Even for a larger body like a Jazzmaster, they're pretty light. So anyhow, if you like this kind of content, please mash down on that subscribe button. Punch the like button, give me a couple comments, whatever. It helps the channel, it helps me bring you this kind of stuff, and we'll see you on the next build. Thanks again.